In this video, we're going to talk about why handling missing data is important for machine learning. First, let's define what we mean by missing data. In the context of machine learning, missing data refers to situations where we have incomplete information about the data we're working with. This could be because some values were not recorded or because they were lost during the process of collecting the data. One example of missing data is in surveys. When people take a survey, they may not answer every question. This means that the data collected from the survey will be incomplete. For example, imagine a survey about people's favorite foods. Some people may not answer the specific question about food, which means that the data will be missing for these people. Another example of missing data is in medical studies. In a medical study, some patients may drop out before the study is complete. This means that the data collected from those patients will be missing. For example, imagine a study about the effectiveness of a new drug for lowering cholesterol. Some patients drop out of the study before it's finished. The data will be missing information about their cholesterol levels and other relevant medical information. A third example of missing data is in financial data sets. In a financial data set, some transactions may not have been recorded properly. This means that the data will be missing information about those transactions. For example, imagine a data set of credit card transactions. Some transactions are not recorded properly. The data will be missing information about those transactions. Why does this matter for machine learning? Well, one reason is that many machine learning algorithms require complete data in order to work properly. For example, if we're trying to train a model to predict the price of a house based on its square footage, we need to have complete information about the square footage of every house in our training data. If some of the square footage values are missing, the model won't be able to learn a reliable relationship between square footage and price. Another reason why missing data can be a problem is that it can introduce bias into our model. Imagine that we're training a model to predict whether a person will have a heart attack based on their medical history. If the data we're using is missing information about the medical histories of some people, our model might end up making predictions that are biased against those people. This could lead to unfair or even dangerous outcomes. So what can we do to handle missing data? There are several approaches that we can take depending on the situation. One approach is to simply drop any rows or columns of data that contain missing values. This is often the easiest option, but it can also lead to a reduction in the overall size of our data, which can make it harder for our model to learn from the data. Another approach is to impute the missing values, which means estimating what the missing values might be based on the other values in the data. This can be done using a variety of methods, such as using the mean imputation. This algorithm replaces missing values with the mean of the values in the same column. This is a straightforward approach that can be effective when the data is normally distributed. You can also try regression imputation. A regression model is estimated to predict observed values of a variable based on other variables. Regression assumes that the imputed values fall directly on a regression line with a non-zero slope. Last observation carried forward is another simple imputation method. This method simply replaces every missing value with the last observed value from the same subject. Here are also algorithms, libraries that are specifically designed to handle missing data. These algorithms can fill in the gaps in your data set so you can still train a reliable model. One such library is the multiple imputation algorithm libraries from scikit-learn. This algorithm uses a combination of statistical techniques to estimate the missing values in your data. To use this algorithm, you need to first import it from scikit-learn. Then you can create an instance of the algorithm and fit it to your data. Once the algorithm is trained, you can use it to transform your data, filling in the missing values with estimates. Let's see how this works in practice. Here's some code that uses the multiple imputation algorithm to fill in missing values in a data set. First, we import the necessary libraries and load the data set. Next, we split the data into features and labels, and then we create an instance of the multiple imputation algorithm. Now, we use the fit transform method to fit the imputer to the data and transform the data, filling in the missing values with estimates. Finally, we can train a machine learning model on the transform data. In this case, we'll use a linear regression model. And that's it. We've used a multiple imputation algorithm to fill in the missing values in our data set, and we've trained a machine learning model on the resulting data. Last but not the least approach is to directly use a machine learning algorithm that can handle missing data natively. Some algorithms, like decision trees, are able to work with incomplete data without needing to impute missing values. In conclusion, handling missing data is important for machine learning because it allows us to use all of the information in our data and avoid introducing bias into our models. By using one of the approaches we discussed, we can ensure that our machine learning models are trained on complete and unbiased data.